Hello everyone, I hope you are doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is yet another query problem, and it's a medium level problem. So today's problem, it says that we have been given an array of n elements and num queries, and in each query we have been given three integers L, R and K, and we have to find the number of indexes that are between L and R, so both will be inclusive, such that the frequency of A of I from index I to n minus 1 is K, right? So it is zero based indexing, it says, and for each of those elements, the frequency from I to n minus 1, that is starting from that particular position till the last position. So before starting the problem, I wanted to show you some of the constraints of this particular problem. So it says that like n is 10 raised to power 3 and q is 10 raised to power 3. So like looking at this constraint only, I can say like for each of those queries, I can traverse the whole input array once, right? So this is my first observation that I need to make without thinking of the solution, right? So I can traverse the whole input array for each of those input queries, right? So this is my first observation. Now let us just quickly discuss this first input sample test case. So in this particular sample test case, it says that the given input array is 1, 1, 3, 4, 3, and there are three queries. First query is 0, 2, 2, the second query is 0, 2, 1, and the third query is 0, 4, 2. We have to output the answer of each query like this, 2, 1, 2. So this 2 will be the answer of the first query, this will be the second query, and this will be the answer of the third query, right? So it's starting from the first query, it says that from index 0 to 2, so index 0 to 2 is here, and we have to tell how many indexes are there for which the value or the frequency of a of I is exactly 2 starting from the index I to n minus 1. So if we see here, if you consider this particular 3, now you will see that 3 is present one time here and one time here, so the total frequency is 2. So this 3 should be considered in the answer, and considering this one also has a frequency exactly equals to 2, because in the whole array its frequency is 2 starting from this particular position. So the total answer will be 2 for the first test case. As you can see, it is 2 here, right? So let us move on to the second query that is given to us in the input. So it is 0 to 1. Now for 0 to 1, what we have to do is we have to start from index 0 and end at index 2. So this would be a range. Again, the range is the same. It's just that now the frequency has changed to 1. So we have already figured out that the frequency is 2 for this one and 2 for this one. Now let us check for 1 present here. You will see starting from this index there is no 1 after it, right? So the total frequency of this one will be 1. So this is exactly equal to this value k. So the answer or the total indexes will be 1 in this case, that is present here. Now as for the last query, the range is from 0 to 4. So let us build a range from 0 to 4 like this. The last one will also be included. So I want it to be exactly 2. So we have figured out for these two it is 2, right? So the answer should be at least 2. Now for 4, there is no 4 present after it, so for this would be 1. For 3, there is no 3 present after it, so it would be 1. Remember that it is not the frequency in the whole array, it's the frequency of present starting from that index to the last index, right? So for that is why for this 3 it is the frequency is 2, and for this 3 the frequency is 1, right? So the input values, that is a of I can be up to 10 raised to power 5. Like this was also mentioned in the constraints. Now a very simple way to do is like if you want to calculate, it is very obvious from the input, and if I want to calculate from the frequency from I to n minus 1 or till the end of the array, a very reasonable method is to use a suffix array. The suffix array will store the frequency of all those elements starting from the ith index till the last index, right? So suffix array would do the thing in this particular case. Now once we have calculated the suffix array, it's very easy to answer each query. Since the constraints are very small, it's only up to 10 raised to power 3. 10 raised to power 3 are the number of queries, and the size of n is also up to 10 raised to power 3. So for each query, even if you traverse the whole array, it should pass in the given input constraints, right? So what do? We calculate the suffix array. So for example, here I have calculated the suffix array. This is the suffix array that we need. So if 1, 1, 2, 1, 2 is the suffix array. Now the only thing that you have to do is you just have to traverse between these two ranges, right? For each of the queries, just traverse through the range L and R and check how many elements are equal to this particular value. So for example, for the first query, we needed to traverse in this particular range, and there are exactly two number of 2's, so the answer would be 2. Similarly, in the second query, we had to traverse in this particular range, and the total number of 1's is 1, so the answer will be 1. And similarly, if you have to traverse for the third query, if you have to traverse in this particular range from 0 to 4, the total number of 2's is still 2. So the answer will be 2. So this is exactly what we have to do. We can calculate the suffix array, and then we can just traverse through all the ranges L and R. Since the like input array constraints are very small, it will definitely pass in this n square solution, right? And even the like question mentions that the expected time complexity is n square only. So how will we store the frequency of all those characters? So for this particular question, since the value of a of I is less than equal to 10 to the power 5, an array would work, an array or vector would work to store the frequency, right? If the values were up to, like for example, 10 raised to the power 9, then we could not have used an array or vector. A map would definitely work. In that case, map would definitely work, since we have only 10 raised to the power 3 number of elements. So at most there will be 10 raised to the power 3 unique elements, right? Supposing that all the elements are different, then there will be 10 raised to the power 3 unique elements, and the size of the map would be 10 raised to the power 3 only. So map will not overflow. That is what I wanted to say. You can definitely use a map, and you can also use a map here, but like for accessing the elements, an array would definitely be better. So this was all about today's solution. You just have to calculate the suffix array, and in the suffix array you just have to like run a for loop for each of the rows ranges L and R given in the input query, and check how many elements are equal to the value k, right? So let me just show you the code now. The code is also very simple for this particular question. What I have just done is I have created a frequency array. So this frequency array will store the frequency of all the elements, right, that I have encountered till now. So I have also created a suffix array of size n, and I have also created a answer array of size num. Num is equal to the number of queries, right? Starting from the rightmost element, that is n minus 1th position, till I am greater than, till I is greater than minus 1, that is till the 0th index. I just run a for loop, and in that for loop, what I do is suffix of I is equals to plus plus frequency of a of I. So for example, if the frequency of the current element is 0, right, and I have encountered the current element once now, so I just incremented the frequency, and this is pre-increment. That is what I first increment the frequency of the element and then store it in suffix of I, right? So that is why I am pre-incrementing the frequency of a of I and storing it in suffix of I. So the next time I encounter the same element a of I, the frequency of a of I would already be 1, right? And the next time it will become 2, and that will be stored, and that 2 will be stored in suffix of I. So that is how this simple for loop is working. Now I just run a for loop for the number of queries. I just initialize 3 variables L, R and K. So L will be the left half, left starting range of the left end of the starting range, and R will be the right end of the range, and K would be the given input given to us in for the query. So I just initialize my count equals to 0. I just run a simple for loop from L to R, right? So I'm including less than, so that is why I've done R plus 1. Now I just do count plus is equals to suffix of j is equals to k. So this is a boolean expression. It will return 1 when this is true. It will return 0 when it is false. So whenever suffix of j is equals to k, my count will be incremented by 1. And finally, I just set my answer of I is equals to count. So this would be the most simplest explanation, or the most simple approach to do this particular question, and at the end I can just return my answer. So this was all about today's solution of the problem, yet another query problem, and it was, like I would say, it says it is a medium problem, but it is definitely on the lower end of the medium difficulty range. So I hope that you guys were able to understand the solution. If you guys did, then you can show your appreciation by dropping a like on this video, and don't forget to subscribe to this channel. It's always free of cost, and if you don't like the content later, you can always unsubscribe. So till the next video drops, keep coding, stay safe, bye bye.